Alright, we're going to do 14.1.3, two variable data and scatter plots. This is the last video of summer school, so I'm super excited. Now I can just focus on helping you all. Did I say it was two variable data and scatter plots? Yes, it is. Alright, I'll be using a little bit of Desmos and a little bit of this, but first let's just talk. Correlation coefficient, or R value. They're talking about the same thing. So let me give one quick example. As you get older, you, my student, as you get older, I gain more teaching experience. It's just factual because I'm continuing to teach. I'm getting more experience. I'm improving, and you guys just happen to be getting older. So there is a positive correlation there. Okay, so there's a positive correlation. But does you getting older, does you going from 17 to 18 give me more experience? Is that what's causing my experience to increase? No, it's not. Your age has nothing to do with my experience, how even if there is a positive correlation. So the key here is that correlation does not mean causation. Just because two things have a similar trend, as one goes up, the other one goes up, just because they have a similar trend does not mean they cause each other. All right? So an example of a correlation that is causation is the more you study, the better you'll do on a test. All right, that is generally proven. Now, there's situations where it could be untrue, but in general, the more you study, as your study time increases, your grade should also increase. That is a positive correlation that should have causation there. All right, as my daughter gets older, I gain teaching experience. Doesn't make sense. As you get older, I gain teaching experience. Doesn't make sense. All right, so just remember that just if there's correlation, the two things may cause each other, but we would need more evidence than just a correlation coefficient to prove that they do cause each other. They may cause each other, but that doesn't mean they do. Now, a correlation coefficient is ranged from -1 to 1. All right? The closer you are to -1 or 1, the closer you are to -1 or 1, the stronger your correlation is. All right, so -1 and 1 are perfect correlations. The closer you are to 0, the weaker your correlation is. All right, the negative part doesn't matter. -1 correlation is the same strength as +1. The only difference is whether as one goes up, the other one goes down, or as one goes up, the other one goes up. It's just direction, not the strength. So -0.75 is equivalent strength of the correlation as +0.75. -0.8 is a stronger correlation than 0.6, and that's not a 7, that's a greater than sign. So a -0.8 is greater than a 0.6. And the closer you are to 0, the weaker you are. So this graph, as the x's are increasing, the y's are generally increasing. So this is a positive slope. So it's not going to be negatives. And this kind of looks like a straight line. It's not perfect, right? It's not perfect, but it's pretty freaking close. That is a 0.9. Because a 0.25 would be scattered. It wouldn't really show much of a pattern, okay? So this is basically almost a straight line, so we can call this a 0.9. It's pretty strong, right? Because a 1 correlation, so a full 1 or a full -1 would be just a solid, it'd be a perfect line. All right, so everything that starts straying from the perfect line, you're getting a little bit smaller from 1. All right, so now this is going down, so it's going to be negative. So the bottom, I have 2 down here and 2 up here, by the way. So it's going to be negative, so I can get rid of my positive answers. Now, this is also kind of a straight line. It's pretty strong. I personally don't think it's -0.95, but maybe it is. But it's definitely not -0.35. -0.35 would not be that close of a straight line. All right, I wish they would have mixed this up a little bit, but I'll say it's -0.95. That seems like kind of strong for where that data is, but the scale could be off. Here's a good one. Now this is there's a general positive trend. All right, so we can get rid of my 2 negatives. right? But it's not that close to a straight line. It's still kind of wild. There is a general positive trend, right? We can see it going positive, but we don't. It's not really forming a line for us compared to the other ones were kind of forming a line. This one's kind of going that direction, but not strong. This would be a 0.4. This would be one of the weaker ones. And I hope you can see that difference based upon those data points that are plotted. Now, which of these is not a possible R value? Well, that's easy. Is greater than 1, we can't have greater than 1, so that can't be it. Which of these R values represents the strongest correlation, the closest to 1? Ooh, right here. Right, because I don't care if it's negative or not. Closest to 1. Weakest, so we're looking for closest to 0. Closest to 0. Okay, so now, how are we going to calculate correlation coefficient? Well, I'll tell you. Pretty fun. Now, we did this the last one where we went to the Desmos, we went to the keyboard, we go to functions, I go to stats, I'm going to look for CORR, core, right? Correlation coefficient, core. If you click here, it tells you need brackets around one set of data, comma, and then brackets around the other set of data. So basically, I just need to, because I'm doing question 5, bracket, and I need to just type in the x values. So all I'm typing in are the x values. I'm not typing the y values, just type in the x values. All right. I close my bracket, there are my x values. Now I need to get my y values. There are my y values. I close my bracket and I close my parentheses. Oh, maybe not. So my correlation coefficient is 0.97. Well, do I have that answer? I most certainly do. All right, so I have to just put it in this form. Brackets around the x values, brackets around the y values, and put comma in between them. Let's do 6. So I need to do core, bracket, I'm going to do 0. So it's a negative 0.93. Pretty easy, huh? The manager of a truck company collected data on the miles traveled and blah, blah, blah. All right, so we got to calculate the correlation coefficient. Well, we know how to do that. Cool, there we go. So I'm just going to type in my y values here. So we get 3, 2.5, and then I need to type in my x values. Excellent. So we got 0.94. So I go over here, I got 0.94. Good, that's an answer choice. Excellent. Use the data to interpret the correlation coefficient. Circle the answer. Okay, so okay. There is a strong, right? So it's close to 1, so it's strong. It's positive correlation between miles traveled and hours required. All right, using Scatterplot, does there seem to be a positive, a negative, or no correlation between age and average times needed to finish? Well, there is positive for sure, and it almost forms a straight line here. What are the explanatory variable? Explanatory is your x, and your response is your dependent. So explanatory is age, and then your response is time. Now, one last thing I do want to talk about is because we didn't really get it. I want to give you a look of what a like no correlate. I want to give you a couple of examples of what no correlation would look like because we didn't really get into that. So go over here. All right, so we had a bunch of examples that we could obviously see were strong positive and strong negative correlations, and we had a medium strength positive at one. But what if I had, eh, that's too willy-nilly. So like right here, I am just willy-nilly drawing things. So this is a no correlation. We can't tell if it's going up. We can't tell if it's going down. This is no correlation. So when they have that idea that it's no correlation, this is what it looks like, right? We've had those examples where it was here, and then here, and then here, and then here, and then here. Now this green, even if we have this one down here, but this green is generally going positive. It's really weak, but it's going positive. All right, now this blue. Again, it's generally going negative, but it's really weak. And then the orange is just completely random. All right, so that's probably not the best picture in the world, but I think it'll be all right.